Hello, this is Bryant Myers. I am a former physics professor and best-selling author, and in this video series on debunking flat Earth, I just want to give you really solid scientific evidence that the Earth is most definitely spherical and that the things that flat earthers are saying are pretty easily proven false, although a few of their arguments are pretty convoluted and take a little more explaining. But today's episode, we're going to talk about the Earth's curvature, and we're going to kind of continue where we started in the last video. And we're going to focus more on the up-down over the horizon curvature in this video. And we're going to really emphasize ships sailing over the horizon. I have a few video clips I want to show you. And along the way, I want to explain to you why this is such definitive evidence that the Earth is indeed curved and spherical. So due to the Earth's curvature, ships traveling over an ocean disappear from the bottom up. This fact is one of the first evidences to confirm that the Earth is indeed a sphere, and one of the very first facts in which flat earthers had to invent various explanations, because it's something we can all so clearly see. And in this video, we're going to really focus on the zooming effects, but in future videos, we're going to get more in depth on refraction, perspective, and some other things, but we'll touch on those in this video as well. So these are kind of the ways that flat earthers try to explain this phenomena, is through refraction, perspective, and of course the zooming that reveals the ships. And you may have seen some of those videos if you've been following the flat earth movement, and they're actually very easy to explain as far as why they don't prove that the Earth is flat. So we'll touch upon that in this video. So I want to begin here by looking at a ship going over the horizon. This is something you may have seen. This is just using a telescopic camera, so it's giving us a very nice image of it. Notice here how very well defined the horizon is. And there's no mirage effects, because typically with mirage effects you're going to see like rippling and distortion in the ship. But as the ship is going over the horizon, and you can see now the hull is starting to sink. In fact, in the old days they used to use before horizon, on horizon, and hull sinking as kind of a measure of distance. They could kind of estimate how far a ship was in basic average conditions. So again, we've known for a long time that we can see the curvature in this way. So as the ship continues to sink below the horizon, and now you can see about, well, not quite half in height, but you can see the full hull is now cut off or clipped off from the bottom, and there is no amount of perspective or refraction that can cause this to happen, because number one, the horizon is very clearly defined, and it's not so when you have, say, inferior mirage or superior mirage effects, which we'll talk about in another video, more detail. But yes, refraction is a very real thing, but it's not going to explain how half of an object is hidden from the horizon. It just won't. And especially you can see here the horizon being very clear. And the ship continues to go over because of the Earth's curvature. And there is just no flat Earth explanation of this that matches reality. Again, they'll come up with all kinds of convoluted perspective and refraction arguments. In fact, those are their top two go-to weapons when they can't explain something. It's refraction or perspective, or density or buoyancy. And they don't give you any equation or model to actually explain, or if they do, it's one that's not based on reality, like their perspective arguments. So now I want to look at a cargo ship here, and this is really beautiful with a Nikon P900 camera. Notice how this large cargo ship, the hull is very clearly below the horizon. In fact, you can almost see and feel the curvature from this image. And it's not a small little ship either, so this is something that you just cannot explain on a flat Earth. And notice you don't see any hints of mirage effects either. There's no rippling, the horizon's very clear. Again, just indisputable proof that the Earth is curved and that it's not flat. Again, no amount of refraction, no amount of perspective arguments can explain how this can possibly happen on a flat Earth. It just can't. There's just no way. I've heard all their explanations, and they just don't work. So this alone, even though I've collected now around 240 proofs that the Earth is indeed curved and spherical, or an obloid spheroid, technically, because it's a little bit of a bulge at the equator, but to me the most visible, convincing proofs are the ones you can see directly. And because most of us can't go to 60,000 feet altitude to see the side-to-side curvature, because you do need kind of a very wide angle of vision in a high altitude to see that. But at sea level, we can all see this curvature with a good telescopic camera. And funny enough, these same telescopic cameras flat earthers will use to, oh, here it comes on the other side of the ship now. So you can see that it's definitely behind that other ship, and it's very, very well sunk below the horizon. Just a beautiful shot. Just absolutely nail in the coffin on the flat earth here. Okay, so because flat earthers know that they have to explain this, let's look at some of their explanations. The first is a lot of flat earthers have the Nikon P900 or P1000 camera, and what they do is they'll typically use a small ship that's right on the horizon. It's not over, because again, if it's over the horizon, it doesn't matter how good of a telescopic camera you have, you are not going to be able to bring back the bottom part of the object that's hidden from the horizon. You just can't. So again, refraction will certainly, sometimes you can see objects that are over the horizon with refraction, but when you have this very clear-cut horizon like this, you can't bring objects back over. You can't recover that. But what they do is they take smaller ships that, just from pure visibility reasons, because the ship is small, when we look out with our naked eye, we just can't see it. It's not that it's over the horizon. It's not like they're not bringing it back from over the horizon, which is what they say they do. They're simply just telescoping in on the smaller ship, and it looks like it's just popping out of nowhere, when in reality it's just a small ship that's, 3 or 4 or 5 miles out, and we just can't see it. It looks pretty amazing because these cameras are amazing, but it's absolutely no proof that the Earth is flat. I mean, just none at all. So that has to do with what's called the angular resolution of the viewer. So our eyes have a certain angular resolution, and we just can't see smaller ships that are out that far. But if we have a telescopic camera, we can certainly bring that back into view. But if the object is far enough out to be obscured by the Earth's curvature, like we just saw with the ship and the cargo ship, no amount of zoom can bring it back. No amount of perspective can bring it back. No amount of refraction arguments can bring it back. It is, these arguments are just wrong. They're not based on the reality that we live in. Now, there are some other things, like, atmospheric conditions can sometimes limit our visibility. But again, that's not something that's going to either prove or disprove a flat Earth or a curved Earth. I'm going to get into this in maybe a little more detail in another video. We did use this nice feature on Walter Bisland's website on how you can see the curvature. We looked at that in detail in the last video. But if you want to properly, because again, a lot of flat earthers have laser demonstrations. You can see this mountain range, you can see this city when you should, and on and on and on. But they don't really use the curvature calculators properly. Meaning, you have to do these things. You have to, first of all, know exactly how high up you are as an observer. How high is the camera up looking? Because the higher the camera is up, the further you can see. How tall are the objects? Again, bigger objects like the Toronto skyline or the Chicago skyline or a mountain range, they're going to be seen from a lot farther away because they're taller. What is the refraction index, okay? Here's something I've seen a lot of flat earthers use some popular calculators online, and they don't have a place to put in the refraction coefficient. And because of that, they are getting false readings. They're saying that this shouldn't be seen 4 miles, or this shouldn't be seen 6, 7 miles away. When it is seen, they think that's proof the Earth is flat, when in reality, it's refraction. So I want to end this video by showing that we do have actual full images of the Earth from space that are not altered. They're not CGI. They're not composite photos. They are taken all in one shot. They're not in any way altered. They're not paintings. So I always want to end with this picture, because you'd think the debate on the flat Earth would be over if they would just realize these are real pictures. So thanks for watching, and we'll see you in the next video. Definitely subscribe to my channel because I have many more videos coming.